Just a moment. Okay, so what you have been doing in the analyze phase, guys? What I have been doing? Yes. What are you doing in the analyze phase, guys? You forgot? Okay, no problem. We will just recall. This is what you are doing in the analyze phase. That is, just got frozen. So in the analyze phase, you are trying to list the possible X factors. What is possible X factors, guys? What is possible X factors? Come on, people, you have to speak up. What is possible X factors? Guys, are you able to hear me? Something wrong? Guys, are you able to hear me?
Yeah, yes.
Yes,
Y equal to
Yes,
y equal to fx.
Y is equal to fx. Okay. So in the analyze phase, we are trying to list out the what is possible X factors. What do you mean by that? What is possible X factors?
Or a
Okay.
potential input
Yeah.
potential
variables
causes.
that may
Okay.
affect the output.
Yeah, I have to recall everything. Actually, don't connect this X with that X. Actually, this X is the possible root cause factors. This X is a possible root cause factors. So let us not connect this one with the Y is equal to F of X. So possible root cause factors in the sense, first week we discussed about it, right? We have been discussing about what are the possible causes for the poor taste of coffee. We have discussed it, right? What are the possible reasons for poor taste of the coffee?
the milk, extra milk, or low
Some milk,
sugar,
yes, low sugar,
sugar level, and the temperature. That is the brew.
and yes. Okay,
Um,
then the high sugar, low sugar, high concentration of coffee powder, low concentration of coffee powder, then high heat, low heat. Okay, then more water, less water. Okay, then anything else? Water, milk, sugar, coffee powder. If any of these things
temperature of
is
the
more,
coffee.
temperature, so hot, so not warm. Okay, so if any of these factors, I'm saying these are all the factors which influences the problem. These are the factors which may influence the problem. We doesn't know which one is the correct problem, right? We doesn't know which one is the correct factor. We doesn't know which one is the correct cause. But we are trying to list out all possible causes. These are called possible causes. Okay. So in the analyze phase, first we have to list out every possible causes. Okay, using the brainstorming. Okay, Y-way analysis. Then you have to go for this uh, fishbone diagram. Do you remember the fishbone diagram, guys? Yes
Yes,
or
sir.
no? Do you remember? Yeah,
Yes,
that
sir.
is yes. The
Yes, yes.
fishbone diagram also helps you to list out the possible causes. Okay, fishbone
And
diagram helps
the
you to,
cause and effect diagram.
yeah, cause and effect diagram, cost and impact matrix. It helps you to list out the potential causes. So once you list out the possible causes, the next step is identifying the potential causes. Potential causes are the one which has the ability to influence and create a similar problem, or which has the ability to create a similar problem, or which can create a disaster to the process. Okay, whether that potential cause also is directly connected with the problem or not, we have not decided yet. The first step is we are listing the possible causes. The second step is we are trying to list out all. Second step is we are trying to filter the possible causes and identify the potential causes. Okay, guys, potential causes. So the potential causes are the one which has a ability to impact or influence the problem, which may be highly connected. That is the second level. Okay, for this we are using the cause and effect matrix or the impact control matrix. Okay, now the third one is the okay. We are trying to find out the potential. Third one is we are trying to find out the root cause. We are trying to find out the root cause. What do you mean by root cause? The one which is actually creating the problem. That is the root cause. That is the third step. Okay. So for that you need hypothesis testing. Got you guys? All of you, are we clear? Are we clear here? Guys, are we clear?
Yes,
Give
yes,
me a yes or no. Okay. So
yes.
first one, listing the possible causes. For that you are using brainstorming, OLEV analysis, and you are going for this cause and effect diagram or fishbone diagram. The second step is we are trying to identify the potential causes. That is the one which has a potential, one which has the ability to create similar problems. Okay, that is potential causes. For that, you are using impact control matrix or cause and effect matrix. The third one is out of the potential causes, you have to list out the root causes. Okay, guys, we are going step by step. So, for verifying the root causes, you are going to use the hypothesis testing. What you are going to use, guys? You are going to use the hypothesis testing. Okay, so the hypothesis testing is, as the name itself suggests, it is quite a hypothetical case. It is quite a hypothetical approach. Okay, so at the end of the analysis phase, you are going to find out the validated root cause. What is a validated root cause? Already I explained about it. Anybody, what is a validated root cause? Come on, guys. What is a validated root cause? Come on,
With the
guys. You have to
evidence,
speak.
the evidence which shows the identified root causes really creates the problem.
Identify root causes really created the problem. Yeah, with the evidence, yes. How will you prove that? See, for example, you are making a claim. Let us say a person goes to a doctor. Okay, he has some body health issues. Let us say he has some health issues. He goes to the doctor. The doctor just meets him and speaks with him, has a counseling session. Okay, speaks with him for 5-10 minutes. Okay, he is making a claim that based on the symptoms and based on the facts said by the patient, he may be having a cancer. The doctor is making a claim. He is making a statement. He is making an expression that the patient may have a symptoms of cancer. What the doctor will do, guys? Whether he will immediately write medicines prescription for cancer? Guys, what the doctor will do
Take
after
the
that?
blood test.
Evidence-based structure.
No, perform some blood test and other required check अलग required parameters.
Okay, so now we have a root cause. We have a root cause which we claim is a root cause. Okay, actually, this both the examples are same. We have a root cause. We claim that is a root cause. As per our claim, we say this cause created the problem. Okay, so now the doctor is making a statement that this patient is having a cancer. So he will send it for the test. Why he is sending for the test? To collect data. Similarly, once you have a factor which is considered as a root cause, similarly, you go ahead and collect data and use that data in the hypothesis testing. Okay, formulas using hypothesis testing analysis, and you can arrive at the root cause. So once a doctor makes a statement, he will ask the patients to take the different kinds of tests, and based on the test, he will validate that this person is having a cancer, that the reason for his poor health is the cancer. So the doctor's ability, claim alone cannot fix a root cause. In many other tools, this is the problem. That is, we claim this is a root cause and we doesn't confirm it quantitatively. We just confirm it based on certain data and we go ahead with the solution. But here we confirm a state, we claim a statement, we make a statement, we make a claim that this is a root cause, and after that we collect data regarding the root cause, and we substitute that data in the hypothesis testing. Different types of hypothesis testing approaches are there. We put it in the approach, and we confirm that by quantitative methods, not by qualitative or experience or other kind of expertise approach. So now, based on the reports from the lab, the doctor has validated the root cause. What is the root cause? A cancer is the one which created the problem, health problem in the particular patients. So making a statement or a claim is a first level. Confirming it through proper data and hypothetical approach is a second one. After that, we are making sure that this is the root cause for this problem. This is called validated claim. Guys, do you got it? Clear? Yes, no? Nobody understood it, huh? So you want me to explain it once again? Okay. Okay, got it. Okay. So now let us move to the hypothesis testing. So what is this hypothesis testing? So guys, if you don't understand it, this hypothesis testing will be somewhat different from the other tools. So you need a clear-cut listening. Okay. It is very different from the other tools, because for making a decision, you are going to have a hypothetical approach. Okay. So what is this hypothesis testing? So it is a data-driven decision-making tool which we are using in the analyze phase. Okay, it is a data-driven decision-making tool which we are using the analyze phase. Why we are using it? To test the assumptions. See, our claim is an assumption. The doctor's claim is an assumption, because without sufficient data itself, the doctor is saying that there is a possibility. Somebody is dragging on the background. Okay, without having any data in the initial stage, the doctor is making an assumption or a claim or a statement saying that you might have cancer. That is an assumption. So in order to validate that, you need sufficient data and some kind of other approaches. So in the hypothesis testing, that is what we are doing. So in order to make sure that the assumption is correct, we are validating through a hypothesis approach. Okay, so this hypothesis testing is a procedure to validate your claim. What is your claim? That low sugar is the root cause, low coffee powder is the root cause. Okay, this particular mission setting is the problem, this particular training is the problem. You may have a claim. That claim is going to be validated through this procedure. That is what we are going to do in the hypothesis testing. Are we clear, guys? Give me yes or no. Understood. Okay.
Yeah, yes.
Okay. So now, what is the role of this hypothesis testing? See, it makes decision based on data, not based on somebody's talent, expertise, experience, historical approach. So you make decisions purely based on. The doctor will not say, "I have 25 years of experience, so I am sure you have cancer." Whether any doctor will say like that, guys?
No. Based on the
He
test
will.
input.
Yeah, that is data, guys. That is data. The doctor is following the hypothesis testing. Same thing. Making decisions using data. Without data, you should not never ever come up to a conclusion in the Lean Six Sigma methodology, especially in confirming the root cause. Because if you decide the wrong root cause, let us say the doctor, instead of cancer, he says it is some kind of kidney issue, then he will be giving a wrong solution. He'll be giving wrong medications. Similarly, if we are choosing a wrong root cause and confirming it, you will be providing wrong solutions, and you will not get the expected results as you think, as you suggest, as you have claimed in the initial stage. In the initial stage, in the define phase, there was a goal statement. Do you remember the goal statement, guys? How should be the goal? It must be smart. Do you remember it? Smart. specific, measurable, attainable, time specific. Do you remember it? Yes, no? All of you have forgotten everything. Being in your day-to-day pressure, you might have activities, you might have forgotten everything. So please ensure you're remembering and recollecting things. Okay, so there you might have given a goal statement that this is the percentage of success we will reach. So if you choose a wrong root cause and proceed, and if you don't get the expected success, obviously it will be a great setback for you. To avoid that, you have to choose a correct root cause and provide the needed solution. So here we are going to decide the root cause based on the data. Okay, after that, you are going to confirm whether the root cause really influences the problem. Okay, whether the health is really influenced by the cancer, yes, we have to confirm it, verify it. Okay, then actually there are okay, we have to discriminate, we have to segregate, okay, real causes from random variation. What is random variation? See, for example, every day we won't feel the same. Do you feel the same? Do your health is same all the 7 days in a week, guys? Whether it is same or it is varying.
Not same every day.
Every day it varies. One day will be very energetic, one day will be very dull, one day you will feel very pathetic and terrible, one day you will be feeling very energetic. It is not constant, right? That is called random variation. That is called random variation. That random variation is very common in natural phenomena. Any natural phenomena will have a random variation. Even if you take a day, the temperature, the climate, the humidity will not remain the same wherever in the year. Okay, that is natural variation or random variation. So we should be able to segregate, separate the real cause for the cancer from the random variation. Okay, so the random variation should not be mixed with the real causes. Okay, so this is what we are going to do in the hypothesis testing. Then actually the hypothesis testing checks, okay, whether the suspected cause, see, you are suspecting this health reason is because of cancer. That is a suspected cause. Whether that's cancer claim, whether it is correct, whether it is significant, whether it plays a major role in the patient's health issue, we are going to check that using hypothesis testing. Then, okay, the variation is due. Actually, let us forget these things. Okay, it will be, we will learn doing this actually in the practical example, so you'll understand the next two. Okay, if I started explaining this, you'll be getting into a different mindset. So let us stop this at this level. Okay, you'll be doing this in the problems. Okay, you are going to have some demo sessions in Minitab as well as in some problems with Dr. JSK. So he will be explaining the next two phases. Okay, that will be easy for you. Next two steps. So the same thing in the hypothesis testing, we are confirming whether our claim is real, whether our claim is the actual root cause. We are going to confirm it using the data. Okay, by making decisions based on data, we are reducing assumptions, we are eliminating assumptions, we are completely away from the assumptions. Assumptions always have a probability chance. That is, if you assume and take a decision, the chance of that decision being correct is 50-50. Like uh, when you are making a task, the chance of getting it right is 50-50, right? Either you may get a head or you may get a tail. When you spin a coin, the chance of getting a head is 50. The chance of getting a tail is also 50. Like that, when you decide based on assumptions, okay, the chance of error is more. Here, we are going to decide based on data. Okay, find the important cause which is affecting our performance, which is affecting our process, which is creating that problem. Okay, and it also looks into the main cause which creates that problem, and it avoids random variation, which I spoke about earlier. Okay, so since you are deciding based on data, statistical evidence, you will be very confident. You won't be having a suspicious, or you won't be having a dilemma mind. Okay, that is why hypothesis testing is very essential and very important in the analyze phase. Are you guys clear about the importance and what is analyze phase and the importance of analyze phase? Give me yes, no.
Yes.
Yes.
Yes, sir.
Okay. Okay. Sorry, it went back. Every time it goes back to the. So in the hypothesis testing, there is a step. There is a procedure. Okay, there is a procedure. What is that procedure? Yeah, I will give you the procedure first, and we will go into the steps one by one. Okay, so this is a procedure for doing a hypothesis testing. First, you have to frame the hypothesis statement. Guys, please note it down. Yes, if you are able to understand this, it will be easy for you to do any hypothesis testing. There are many types of hypothesis testing. You'll be able to understand them all. See, first you have to frame the hypothesis statement. What is a hypothesis statement framed by the doctor? Anybody? What is a hypothesis statement made by the doctor? The doctor
Maybe
said,
there is a cancer case.
Patient have
yes,
cancer.
Suspecting
Maybe.
cancer.
yes, the health is affected because of cancer. So, like this, you have to create a hypothesis statement. Actually, we have two types of statement. One is null hypothesis statement. Another one is alternate hypothesis statement. Okay, the first step in hypothesis testing is you have to make a statement. The next step is you have to, inside that first step, there is an additional step, sub-step. That is, you have to make a null hypothesis statement and alternate hypothesis statement. What is that null hypothesis statement? That is, the doctor is making a claim that your health is affected because of cancer. If you take that claim as it is, if you accept that statement as it is, that is null hypothesis. It is represented as H naught. You guys got it? It is represented at H naught. Okay. Then there is another statement called alternate hypothesis. The name itself, alternative hypothesis, right? So it means it is opposing the null hypothesis. So what does it mean? Actually, it is the opposite of the null hypothesis. That is, it contradicts the null hypothesis. It says that the statement is the statement of difference. The statement of difference. What is the null hypothesis? Null hypothesis says, yes, it is true. The claim is true. Alternate hypothesis says the claim is not true. Guys, I am not saying false. You have to listen me. You have to listen me carefully. Null hypothesis says, yes, the doctor's claim, yes, as it is. The statement is same. The statement is same. Null hypothesis says the statement is same as it is what the doctor says. There is no difference. Okay, there is no difference. You are saying, yes, because of poor training only, so many rejections happen. Yes, that is true. That is what null hypothesis says. Alternate hypothesis says, no, that is not the cause. That is what alternate hypothesis says. Alternate hypothesis is represented by H1 or HA. Got it, guys? Are we clear about null hypothesis and alternate hypothesis? Okay, next, I will show you an example. Some of you might be having some difficulty in understanding this. Okay, there is a bulb manufacturer. Okay, the bulb manufacturer is making a claim. What is the claim? He says, the average lifetime of the bulb which we are manufacturing here is 1,000 years. So if you take a look at the bulb, all the electronic components will be having lifetime in hours. Have you guys noted down? Have any one of you noted down? All electronic components will be having lifetime in hours only. Similarly, here the manufacturer is making a claim that the lifetime of the bulb is 1,000 hours. Okay, then what could be the null hypothesis statement? Any one of you, I want you to give me the null hypothesis statement. Guys, I want you to give. Yes, one of you have posted it. No need to interpret H naught symbol. It is just a symbol. Perumal, it is just a symbol. Null hypothesis is represented by H naught.
H naught. Understood. Thank you.
H naught. That's it. Okay. You are going to make H0. You are going to say H0. Okay, now I have given you an example. You have to say the H0. As per the statement of the owner, manufacturer, the average lifetime of bulb is 1000 hours. So what is null hypothesis here?
Yes, the bulb life will exist for 1000 hours.
Yes, very good. The life of the bulb is 1000 hours. It is accept as it is. It is accepting as it is. That is no change, no improvement, no difference. You take the claim as it is. That is called null hypothesis. Okay, company wants to know another example. A manufacturing company wants to know whether the new machine produces defects. What is a null hypothesis? Yes. Does the new machine improve quality? They have a doubt that the new machine is not improving the quality. So null hypothesis is same. Yes, the machine does not improve quality. No, there is a doubt. That is, they are making claim. Yes, your claim is accepted. Null hypothesis, same as it is. Okay, then where is my example? Just a moment. Every time I'm losing this slide. Just hold on. So the null hypothesis in this example is the manufacturer's claim of 1000 hours is accepted. Is it as it is? What about null hypothesis, guys? You have to give me the null hypothesis. What about the null hypothesis? Guys, what about null hypothesis?
Assumed to be true unless proven.
Assumed to be true unless proven. See, actually, your alternate hypothesis is should be contradicting the null hypothesis. Your alternate hypothesis should be contradicting the null hypothesis. What does it mean actually then?
It should not be the same. It should oppose the statement of null hypothesis.
Yes, actually, the manufacturer is claiming 1000 hours, but actually it is not so. Very simple. The manufacturer is claiming 1000 hours, but actually it is not so. That is what alternate hypothesis says. Alternate hypothesis is very simple. Yes, we don't know. We are contradicting null hypothesis. Alternate hypothesis is very simple, guys. It is just like an opposition party in the legislative assembly and parliament. Whatever the ruling party says, the opposition party will 99% oppose it. Alternate hypothesis is the same thing. Null hypothesis says 100 hours, 1000 hours. We say no. That's it. Very simple. We say it is not true. That is the alternative hypothesis. Okay, so your first job is to create the null hypothesis and alternate hypothesis. Okay, so you have done here the first step. That is, you have framed the hypothesis statement. Under the hypothesis statement, you have to make null hypothesis and alternate hypothesis. The character of null hypothesis is, this is the character of null hypothesis. It considers whatever you say as it is. It is like, okay, just accept whatever he said. See, the ruling party people, for example, if the prime minister says anything, all the ruling party people will agree with it, right? That is what null hypothesis says. Yes, we accept, no change. Alternate hypothesis is like opposition party. Whatever the ruling party says, they will oppose it. We are contradicting. That is alternate hypothesis. So we have completed the first step. Second step, fix the level of significance. What is this level of significance? This level of significance is the percentage of error which we are ready to accept. What does it mean? Actually, the doctor is going to collect the data from the laboratory. Are you sure that the laboratory report will be having 100% accuracy?
No, sir.
Guys,
No.
Unless it is authorized by any.
There will be error due to random variation. See, there will be error due to random variation. but it must be within acceptable limit, right? Got it? It must be within acceptable limit. Then that error is agreed. If, for example, you are having a clock, you are having a watch. Suppose if the variation or the error in the watch, if it is within plus or minus 30 seconds, you won't mind it, right? You won't bother about it. But if it is having 30 minutes variation and if you don't know about it, it is a risk, right? It is a danger, right? For example, you might be having a train at 6 o'clock. So it may be just 30 minutes travel from your home to house to your railway station. So if the clock is slow by 30 minutes and if you are not aware about it, you will be starting by 30 minutes late. So obviously the chance of missing the train is more. Why? Because the data which was provided to you has more error and you don't know about it. Similarly, here what we want to do is the doctor got a report and the doctor knows what is the percentage of error that is present in the data in that report. That error must be within 2% when it comes to certain test. When it comes to certain test, it must be even 1%, less than 1%. Then only the result will be considered as a genuine one and for it will be considered for making decisions. That is why doctors prescribe certain laboratories for making tests, because many laboratories they are not calibrating the equipments, they are not calibrating the diagnostic equipment. So the error in the equipments will be more, and as a result of that, they will not be aware of it. If it is more than 2, 3, 4%, then the data which is provided by that diagnostics will not be good for making decisions. So the doctors will accept any data if the error is less than within this particular range, within particular percentage. Similarly, here we are fixing that error level. We are fixing that, we are saying it as level of significance. We are saying that a level of significance. What do you mean by that? Okay, the percentage of error or risk which we are ready to agree, which you are ready to accept. Normally, it must be between 1 to 5%. How much it must be, guys? 1 to 5%. Okay, it must be within 1 to 5%. That means if the error present in the data which we are collecting to make the decision, if it is within 5%, we can accept that data and decide whether the patient is having cancer or not. This is called level of significance. It is called as alpha, and we call it as alpha risk or risk. Do you guys get this step? Yes or no? Yes or no?
Yes, sir.
Okay, then you want first, before going and collecting the data, we are fixing the level of risk. Before going and collecting the data, we are fixing this error of risk. Okay, then you go and collect the data now. If you have the data, it is well and good. You can make the decisions. In the case of the doctor, he doesn't have any data. Even though he has, if the patient is providing some data, the doctor will go for additional data collection because he wants to be very clear that this cancer is a root cause for the health issues. You want to be very sure about. So he will make sure that the data is collected fresh once again. In our case also, if there is sufficient data available regarding that particular hypothesis, regarding that particular cause, okay, you can refer it. Otherwise, you have to create a data collection process. How? Develop a similar situation and collect the data once again. Create a similar process conditions and collect the data once again. See, for example, you guys might have seen this police criminal investigations. See, when the accused was caught, okay, the police will ask him to recreate the same activities in the same spot where he committed the crime. Have you seen it in news channels, guys? Have anybody seen it? Guys, do you understand what I'm saying?
Yes,
See,
yes, yes, yes.
See,
Yes.
when a thief or a murderer has committed a crime, the police, after catching him, will ask him to go, will take him to the same spot where he committed the crime and they will ask him to do what he has done on that particular day, how he committed the crime, and they will record everything in the video. This is generating data by conducting similar process conditions. This is called generating data by developing, creating, conducting a similar process conditions. Okay, because the police doesn't have sufficient data. They don't have 100% data. They don't have sufficient, okay, capable, adequate data to decide. So they create it. That is what we are going to do in the third step. Got it? Okay. So after that, you have to use the data and calculate the statistics. That is, you are having a lot of exams, different types of hypothesis test, Z test, Z test, Z test, okay, regression analysis, correlation and proportion test, one sample t test, independent t test, PAT test. Okay, one way, two way, lot of tests are there. It's all very easy, guys. Don't worry about it. Okay, so you are going to use the correct statistics and estimate that error. You are estimating that. See, in the second step, you are fixing the error. You are not estimating the error. Guys, you have to be very clear. In the second step, you are saying, okay, I will accept error if it is 5%. Perumal may say, sir, in our process, we cannot accept error. We can accept only 0.5% error. See, for example, in the case of brakes, the error acceptable is less than 1%. In the case of airbags, the error acceptable is 0.01%, because the airbags cannot fail. If it fails, the patients will die. In the case of aircraft testing, no chance of error. Error should be less than 0.01%. So you are fixing the error before starting the data collection. That is, it should not go more than 5%. It should not be more than 5%. Never ever it should not be more than. So you are fixing it. My process is okay with 5%. My process is very sensitive. You can have only 1%. You have to fix it. So in the step 4, you are using the test and calculating the required statistics. In the test, you'll be getting the error percentage. That is, you'll be getting alpha value. So, guys, are you able to understand these 4 steps here? Anybody having doubts? Any doubts, questions? Yes, you are going to learn this for the next 2 hours. GSK is going to handle the session. You are going to learn in detail. Just what I said is an introduction. Okay, outline, a frame structure, structural frame only I have given. Are you able to understand these 4 steps? Give me a yes or no. Based on that only, we will go to the 5th one.
Yes, sir.
Yes,
Anybody
sir.
having questions, doubts? Okay. So, now we have calculated the alpha value. Now, if the error, if it is greater than, less than 5%, you have to use the data and your process knowledge to confirm that claim is true. Guys, let me repeat it. If the alpha value which you calculated in step 4, if it is less than the alpha value, I am not saying if it is less than 5%, you have fixed the alpha value for your process. You may see for a medication process, you cannot fix the alpha value as 5%. For a medication process or for a medical surgeon, a medical surgery, you can fix the alpha value less than 1%. So if the statistics which you have calculated, if the alpha which you have calculated, if it is less than the one which you have fixed, use the data and your process knowledge to confirm that this is the root cause. If the alpha value, if it is more than the one which is fixed by you, then use your process knowledge alone. Actually, it means you have to, that cause may not be the correct one. That is the actual reason. But here what we are concluding is you can use your process knowledge in this case. That is what we are going to do in the hypothesis testing. Okay, so in the hypothesis testing, first you have to make a claim statement. The claim statement It may be the assumption. That is, you are assuming, yes, this is maybe the root cause. Okay, based on your existing data, you are just assuming that this may be the root cause. Yes, this machine setting is the problem. Okay, this particular training process is not provided sufficiently, so this may be the problem. So you are fixing the hypothesis statement. Under the hypothesis statement, you have two types. One is null hypothesis, which says whatever you say is correct, no difference of opinion, no change, no variation. That is null hypothesis. Then alternate hypothesis, it is just like the opposition party. Whatever the null hypothesis says, it doesn't accept, it doesn't agree. Then you go for fixing the level of significance. That means the alpha, that means the risk which you are ready to take regarding the data. The risk which you are ready to take regarding the data. That is, the alpha level should be fixed within 1 to 5% only. You have to fix it, not the Lean Six Sigma fixes. You have to decide the alpha level. Okay. You should be fixing it between 1 to 5, not more than that. Okay, then you go to the data which is available for you. If it is sufficient, if it is adequate, if it is enough, that is good. If it is not, if it is insufficient, if it is inadequate, if it is not enough to make the decision, you go and create a similar condition and collect or generate data. After that, using the data, you calculate the hypothesis test statistics and estimate that uncertainty error, that is alpha. Okay, now you have the alpha in your hands. If the alpha, if it is within 1 to 5%, I am not saying it is 1 to 5%. It is the alpha is fixed by you. If your alpha is 2%, for example, you are calculating alpha, and for you, you are getting as 2%. But what you fixed is less than 1%. What you fixed is 1%. Guys, let me ask you a question. Let us say who is Mahesh is calculating alpha. Is after calculating, he found that the alpha was 4%. But the one alpha which he fixed in the second step is 2%. What will you do, Mahesh? What should be Mahesh's decision?
The error is more than allowable limit what we have fixed. So we have to, instead of data, we have to use our process knowledge, sir.
Yes, the data seems to have more uncertainty than our allowed error. Okay, so you simply cannot rely on data. So you have to go with your process knowledge. That is what must be a decision. Okay, let me say one more example. Permal has fixed uncertainty. Permal has fixed an alpha value of 2%, but the process seems to the alpha value seems to be 1%. What will you do, Permal?
So we have to go with the data and knowledge.
That's very good. That's it. This is what you are going to do. That's
Also,
very simple.
Is there any standard or recommendation? What should be our what is it, risk?
See, your process knowledge
Can be my
decides
confidence
your
level.
yes, your QAP will decide. See, for example, a QAP for a missile manufacturing will be very stringent. For a satellite manufacturing will be very stringent. It allows a error of only 0.1%. If you see the machining parameters, it will be O1 or it will be O01 like that. See, based on your process knowledge, you'll be able to fix it.
Okay. It's not, there is no standards. It's based on our process.
Obviously,
and our requirements.
because every business process varies, right? See, for example, when you are making a coffee, you can add the quantity with more variations. But when you are making a medicine, whether you can have the same variation like a coffee?
No.
Who decides it?
Based on the, what is that? Customer requirement, the manufacturer decides it.
Yes, you are the manufacturer. You have to decide it.
Okay.
Very simple.
Understood. Thank you.
So you have different types of test, guys. Okay, based on the type of data available, you have to choose the type of test. Dr. Siva, are you there? I think he's not still available. Okay, based on the type of data available, okay, you have to choose the type of test. Z test, Z test. When you have to compare averages or proportions for large samples, when the samples is 1,000, sorry, when the samples is 100, 50, 75, okay, or mean proportions. And when you have more than one or two samples, when you are trying to study the large set of populations, you go for Z test. Okay, then Z square test. It is a categorical, that is based on categories, multiple categories. For example, if you take our participants, they will be from different categories. One might be from industrial, manufacturing industry, quality. Some of you might be from automobile industry. Some of you might from software industries, banking sectors. Okay, from food industry, from hospitals management, hospitals, tourism and management, hotel industry. All of you may be from different field. That is category. So if you are trying to work with different categories, okay, then you have to go for chi-square test. When you are trying to go with this F test, you have to go for just two samples, two set of samples. Okay, and the data also must be continuous. So like this, you have lots and lots of, okay, hypothesis test, regression analysis. You're just going to find out the relationship between variables. Okay, X and Y variable. See here the variable is the root cause and the problem. For example, a person is consuming more calories in the night. Whether it will have a implication in the weight, whether it have a connection in the weight or not. What do you say, guys? If a person is consuming more calories in the night, whether it will increase his weight, body weight.
Yes.
What do you say?
Yes.
So,
Yes.
so there is a relationship between the X and Y. So if you want to study about that relationship, you can go for this regression analysis. Then what is the strength of that relationship? Whether it is having 75% strength, 80% strength, 90% strength, you can calculate in quantitative data using correlation Pearson coefficient. We saw that last week, I believe, right? If you calculate it, the value of Pearson correlation coefficient must be in between -1 to +1. If it is 0.9, it is strongly connected. If it is, guys, do you remember this or forgot? You have forgotten it. I think you might have forgotten it, right? I will show you. It is in the analyze phase. It is in the end of the analyze phase. Do you remember this, guys? I think you remember this, right? We have seen this, right? In last week. Analyze phase. Yes or no? Forgotten it, huh?
Yes, yes. Remember.
Yeah. So if the correlation coefficient is 0.9, it is strongly connected. Positive connection. Like this, you can determine the strength of connectivity. You can determine the strength of connectivity. For that, you can use the correlation and regression. Then proportion test. It is used for comparing attribute data. Yes or no, true or false, better, best, poor, good. Like this, there is attribute data. Count. To compare and find out, make a decision of attribute data, you can use this proportion test. Similarly, one sample t-test. See, it gives a simple, see, this is, I have added this slide additionally for your understanding. Actually, you are going to do most of this test by calculation. So you don't have to worry about it. Okay, don't worry about this test. And all. It is just for your idea only. I am giving a intro. It is just like a teaser for this hypothesis test. One sample t-test. Suppose the name itself is one sample. So you are going to use only one sample. Okay. Compare sample, the sample mean with the known value. If, for example, the average temperature of Chennai must be 36 degrees centigrade during the summer. But in this summer, it is 40 degree. So we are saying it is more, right? So we are going to compare with the standard known value. Then independent t-test. So the name itself says independent. So you are going to compare two independent claims, independent groups. Okay, that is what I mean by independent t-test. Paired t-test. The name itself says you are going to compare two known groups, same group. Okay. Then one-way ANOVA test. This is also quite interesting. When you are going to compare the average of more than two groups, okay, you have to use the ANOVA test. Okay, two-way ANOVA test. When you are having multiple groups, multiple causes, you doesn't know which one is a cause. You have to go for the two-way ANOVA test. Okay, this is how you are going to use the hypothesis testing. Okay, to confirm whether the claimed cause, whether the one which you assumed is a root cause or not. Guys, are you able to understand this? The introduction, was it clear? Any questions? Any questions, guys? So if you have any questions, you can ask. Okay. See, you might be having some queries, but that will be clarified while you are working out, while you are solving the problems. So don't don't try to jump into conclusion. Okay, you have to just wait until you do those calculations. Dr. GSK will be taking the sessions and be explaining you everything in detail. Okay, no need to worry about it. Okay, so the important step in the analyze phase is deciding the root cause, and that too you have to make sure that you are deciding the correct cause as a root cause. Okay, so you have to decide that correct cause as a root cause. If we fail here, we will be moving towards a wrong solution. Obviously, the entire project might be having a unexpected end. Okay, that is, you have expected some kind of result, some kind of success rate, but you won't be able to reach it because a wrong cause has been selected, confirmed as root cause, and you will be choosing the respective solution. So that might not give you the expected results or the results which you assured your top management in the defined phase in the project chart. So we have to be very clear in this hypothesis testing, in this third step of this hypothesis analyze phase, that is deciding the root cause. So that is what we are going, for that we are using this hypothesis testing. Okay, actually this hypothesis testing is learned by all of us. Anybody who has completed 12th standard might have learned this hypothesis testing in your school days, but we don't remember that. We doesn't want this particular topic because it was quite a confusing topic. It is very difficult to explain this without confusion. All of us have learned this as numerical methods in our 12th standard, in 10th, 11th, or 12th, but we won't remember it because it is quite a different kind of topic which is extremely different from others. That is why it plays a major role here. It plays a major role here. Okay, guys, so actually it is better we go for a break and you can join after 10 minutes and Dr. GSK will be joining you in the meantime. Any questions? Any questions, guys?
Nothing,
I think
sir.
it is. Yeah.
No, it's okay.
Thank you.
Because if I started the topic, I cannot stop for the next 1 hour. So let us go as per the schedule. Yes, any questions you can ask, or you can go for a break and you can join by 8:15 and Dr. GSK will be joining you. Okay, guys?
Okay, sir. Thank you.
Okay. Thank you, sir.
Thank you. Thank you.
Yeah, I prefer to come on the camera. Let's have an interactive session. I think you have some important topic built for the day. Hypothesis testing, right? ANOVA, 2 sample t-test, 1 sample t-test, paired t-test. So these are the hypothesis tests we are going to discuss, which will help you to validate your root causes. Hope all of you have some idea about hypothesis testing because Dr. Ravi would have taken you through the introduction. Is my point correct? Understanding correct? Yes. Please
Yes.
respond.
Yes, sir.
Yes, sir.
So what's your understanding now? What do you think is hypothesis testing? Come on, please speak something. What is hypothesis testing as of now? Come on.
Collecting the root causes.
Root causes?
Collecting the
Coming
root causes. Root causes.
Okay. Okay. No. Hypothesis testing is after identifying the root causes, after collecting the information about the root causes, whether the informations are correct or not. Are they assumptions or are they facts? We can validate that with the help of hypothesis testing. Okay. So in order to understand, let us have an example, a simple example, and then I will take you through some case studies of hypothesis testing. So I'm just opening the Minitab thing so that we can also parallelly make use of Minitab or doing the hypothesis test. Okay. So hypothesis test. Hypothesis testing. Basically, it is a claim validation procedure. It's a claim validation procedure. And in the context of root cause analysis, the claim is about the root cause. Claim is about the root cause. And in hypothesis testing, there are two statements, right? One is null. What is the other one?
Alternate.
Very good.
Alternative.
Null and the other one is, alternate. H1 or HA, right? And the null is always saying that the factor is not a root cause. Am I correct? When I say the suspected factor is not a root cause, then this is null. That means factor X is not critical to Y. This is how you have to state, right? Or otherwise, X has no effect on Y. You have to use any one of this, or X has no relationship with Y, or no effect. Yeah. A difference in X makes no difference. Same relationship, no difference in Y. So these are all of them are called null hypothesis. So if the difference in X doesn't make any difference in Y, that means it's called equality, statement of equality. Mathematically, an equal to symbol should come. Mathematically, an equal to symbol should come. Are you with me, all of you? Null hypothesis?
Yes, sir.
Please
Yes, sir.
confirm. Yeah. And then the alternate. I just have to make the opposite. Factor is a root cause. Factor X is critical to Y. X has, you can also read along with me. X has significant effect on Y. X has significant relationship with Y. Difference in X makes significant difference in Y. That means statement of inequality. Inequality means you will either have greater than or less than symbol. Equality means mathematically it will have an equal symbol. So this is your hypothesis testing step number 1. This is your step number 1. And once this is done, you can move on to step number 2, where you have to fix the level of significance, which is also known as alpha disk. Generally, it is 5%. 5% means 0.05. Right? So what does it mean? Level of significance 5% means what?
0.05.
Yeah. It refers to the risk
Acceptable
of
error.
rejecting a true null hypothesis. 5% refers to the risk of rejecting a true null hypothesis, known as type 1 error. True null hypothesis, when you reject it, it's called type 1 error. Are you with me, all of you?
Yes, sir.
This again means 95% of the time the true null hypothesis is accepted. But in statistics, we call it fail to reject. Hope you all understand. Right? So fail to reject. Step number 2 is done. Now step number 3. Step number 3, select the hypothesis test. Select the hypothesis test. That is, based on
Similar.
data type of Y and X. Okay. If data type of Y is continuous, then you must use something known as test of averages. Data type of Y is discrete. Then you have to go for a test of portions. Okay. So step 3 is done. Now step 4. Step 4 is conduct the experiment and calculate the required statistics. Calculate the required statistics. Step number 5. Check whether the calculated statistics is within the 90% confidence interval or outside the confidence interval. Right? So here, if the calculated stats, the calculated stat is found outside the interval. What interval? Confidence interval. Then we should reject the null. Otherwise, we need to reject the null. So maybe step number 5 is decision making, right? Decision making. Step number 5 is all of you have vanished. So I'm only teaching to myself. Yeah. So decision making. Step number 5 is actually decision making. And how we make the decision, I have explained here. You just have to check whether the value is within the confidence interval or not. If it's within the confidence interval, then within the confidence interval, don't reject. But if it is outside the confidence interval, reject. Once we do an example, it will be very, very clear. And alternate method, because this is, it is hard to understand. Alternate method is if p value is less than 5% or 0.05, you reject the null. Otherwise, fail to reject the null. Okay. So what is reject the null? Reject the null means the factor is validated cause, and hence action is required. But what action the project team has to develop? Do you understand, all of you, all the steps? Tell me.
Yes,
We
little bit.
need to have an example, then only we can understand it. At least.
Somewhat.
We will have example, don't worry. I'm just putting all these things in the chat. Okay. You want, you can copy, right? So now, let us take an example. Example. We all know Virat Kohli, right? All of us know Virat Kohli, right?
Yes, yes.
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 Let us say is based on the run score, based on the data available, his batting average is 55 plus or minus 5. That means this refers to 95% confidence level. This refers to what? 95%? Which again means in 95% of the matches he played, his score is between 50 and 60. Are you with me, all of you? So
Yes,
the
sir.
lower confidence limit is 50. The upper confidence limit is 60. 50 and 60. Okay. So now, if you look at the Kohli's performance, it will be like a bell curve. What is the average? 55. And upper confidence limit is 60, no? That is somewhere here. And now, maybe the lower confidence limit is here. So this is 50, this is 55, and this is 60. Hope you all understand. This is how the Kohli's batting performance is distributed. Okay. So now I would like to consider only one side of his limit, which is let's say the 60, and the average is 55. Now let us assume the 60 as the upper confidence limit. 60 as the upper confidence limit. And so the area to the left of this 60 corresponds to 95%. So the right side will correspond to how much? 5%. Now the assumption is 95% of the matches, his score is 60 and below. 95% of the matches, his score is 60 and below. 5% of the matches, his score is above 60. Maybe you might have scored, centuries and many other things. But that's the, logic. So now, what I want is, I want to understand like, let's say I appoint a coach. From New Zealand. A New Zealand coach has been appointed to study whether the appointment of the coach can significantly improve the batting average of Kohli. So now what happened? The coach is giving 3 months, 2 to 3 months of coaching, and afterwards, Kohli is allowed to play another tournament, and the tournament is played. After the tournament is completed, the batting average of Kohli is calculated. Now, the batting average of Kohli is found to be 56.5. Now, all of you tell me, what is your opinion? The appointment of the coach is useful or not useful?
Useful.
Useful.
Okay. So, 56.5 appears somewhere here. Am I right? 55. This is 60. This is appearing somewhere here. So now, you mean to say, yes, the appointment of the coach has improved the batting average from 55 to 56.5. Would you like to give this credit to coach and make the appointment of the coach permanent for 1 year? maybe he has to be paid, in crores. Let's say he's paid 2 crores a month or 3 crores a month. And now, are you doubtful or are you very confident that the average has improved?
No.
Come on, all of you.
Already,
What do you see?
already 5 or minus we given, so it is not kind of improvement.
Already Kohli can easily take his average up to 60 based on the past record we understood. We know his normal performance. And now, whatever improvement we witness here, this may be a random improvement. Yes or no? What is random improvement?
Plus or
This is
plus
not
or
because,
minus 5.
Yeah,
this
yeah.
is not because of the appointment of the coach. This is something on its own. Kohli himself can improve his average sometimes, isn't it?
Yes, sir.
So
Let me just ask one question. Why do we want to give this plus or minus 5 there? Because the average we can get the accurate value, and after that we are mentioning it is 56.5. So before, why do we need to go for this plus or minus value? Could we take it as 55
plus or
only?
minus DC, the plus or minus 5 is known as a margin of error. The plus or minus 5 is known as margin of error because every time Kohli can't get exactly the average of 55. If you look at his match score, it's not 55 always. It is it is vary depending on the variation, the margin of error,
So
that
that value
statistics.
is average.
Huh?
We call it average. So
See,
average will be
average is just the central value. If you again allow Kohli to play some matches, there is a no chance that his average can move to the right or move to the left. Definitely, it will move to the right or left. Have you ever maintained the average over and over again the same value? Have you ever able to maintain?
no.
Then everybody need Then definitely there will be some fluctuation. Of course, in statistics, always all your findings are in an interval only. If your findings are just a single unique value, then this is the field is called mathematics. Whereas statistics, the answer is always in an interval. And the interval is known as confidence interval. There is an upper limit known as upper confidence limit. There is lower limit known as lower confidence limit. The distance between average and the upper limit is known as margin of error. Margin of error will be there on the right as well as on the left. There are statistical formulas, right? To find out, to quantify how much is the margin of error. Here we simply assumed the margin of error is plus or minus 5. All right. So now this increase in the the batting average, 56.5, 1.5, there is, it can be random also because the revised, what do you call, the recent average calculated is still seen inside the upper limit. Can you see that? It's still seen inside the upper limit. So in this situation, giving this, improvement to the credit of the coach is not the correct idea. So we in this case, we consider the improvement as random. So in this case, what is the H naught? What is the H naught? Shall I say coach is critical or coach is not critical?
Coach is not critical.
Not critical.
Yeah,
Not critical.
very good.
Not critical.
Very good.
Not critical.
Yeah, 1 minute. I will rewrite. Let me, yeah. H naught will be, it's not writing properly. Okay. So H naught will be, which is not critical. Not critical to batting average, the improvement in the batting average. So this null, since the calculated statistics found inside the interval, shall we reject the null or fail to reject the null? Fail to reject the null, isn't it? That is what we studied in the procedure, right? Fail to reject the null. So the cricket board concluded that appointment of New Zealand coach is not actually giving, the desired improvement. Say they could now proceed with either cancelling the appointment or maybe, hold it for some period of time. So let's say they now tried with another coach, Australian coach, right? An Australian coach also gave, some kind of coaching. And then Kohli is playing another tournament. And now his batting average again X bar, new batting average. X bar is nothing but batting average. And what is the upper confidence limit? We earlier know
60.
60. Now Kohli, yeah. Now Kohli has played another tournament. His batting average is found to be now 68.5. It's not 56.5. Now it is 68.5. Now look at this in the graph. This is Kohli's performance. Here it is 60, 95% this side, and this side is how much? 5%. And the center value is 55. Now you just have to find out which side the 68.5 will come. 68.5 will come
Upper side.
upper side. Somewhere here. Somewhere. Yeah. Somewhere here. Am I right? Now the upper confidence limit is getting over here itself. The upper confidence limit is getting over here itself. But our new average, the calculated average, is appearing outside the confidence limit. Can you see that, all of you? Now, in this case, we can conclude that the improvement is because of the appointment of the Australian coach. Now, also you might ask, sir, now also this also would have happened randomly. This also would have happened randomly. But the probability of 68.5 happening randomly is statistically, the definition is area to the right side of the observed value. Now, please tell me the green color area which I hatched on the right side. This is called, this area is known as p-value. What is p-value? Probability of significance. Now, tell me the p-value. Can this p-value be more than 5% or less than 5%? From here, from this line up to infinity, what is the total area? Total area is how much? 5%.
5%.
But we want to calculate the area from this line up to infinity. That means this is definitely 5%, yes or no?
Yes.
You understand?
Mm.
So this is the so see, every time calculating the upper confidence limit and checking whether your average is outside the limit or not is a tedious job. To avoid that, statisticians have introduced the concept of p-value. So what is this p-value, if you ask me? P-value is nothing but the probability. I will type it here. P-value refers to the probability of observing the calculated statistics probability of observing the calculated statistics on or above the calculated value. That's all. Whatever value we calculated the average to be 68.5, isn't it? So for the statistics to appear exactly at 68.5 or even above, and that is why I've drawn like this. So here is our 60 and 68.5 is here. So on 68.5 or above, that refers to only this area, isn't it? But
Yes.
what is our understanding earlier? When we know about Kohli, 95% of the matches, his score is below 60. But 5% of the matches, his score is above 60. So this area is 5%. So with respect to that definition, 68.5, the associated p-value is below 5%. That is for sure. So that is why we confirm. Yes, we conclude the appointment of the Australian coach is critical to the batting average. I mean, there is a significant improvement in the batting average while appointing the Australian coach. So we confirm that appointment of the Australian coach is critical, but appointment of New Zealand coach is not critical. So the appointment is confirmed for the Australian coach, and it is the improvement observed with the New Zealand coach is considered random. So this is the whole idea of hypothesis testing. And now test selection, hypothesis test selection. If Y is continuous, you all know what is continuous data, isn't it? You all know continuous data. What is continuous data?
Measuring value.
Measured value.
Measurable data.
Yeah, measured value. So now the measured value. So now X variable, whatever the X variable. Let's say the Y variable is turnaround time of a process. Turnaround time of a process. Which is a measured variable. X variable. X variable is X variable is, let's say this is a kind of diagnosis, laboratory diagnosis. X variable is laboratory. And in reality, there were 4 labs: lab 1, lab 2, lab 3, then lab. Now, what do we understand is the factor lab exists in 4 levels. Now, what do we really want to understand is whether the turnaround time is dependent on the lab or not. Whether the turnaround time is equal across all the lab or not. What will be the null hypothesis here? Can somebody help me with the null hypothesis? A statement of null and statement of alternate so that we can proceed with step number 1. Tell me, who can help me? What is null hypothesis here? The laboratory is not critical to turnaround time. Yes or no? Am I correct or not? Or in what other way I can define? That for A equal to that for B equal to that for C equal to what do you understand from the statement? What am I telling here by using the equal to symbol?
There is no
That
difference because of laboratories.
Very good, excellent. So that is another way of writing it. There is no difference in the that, right? Because of the labs. Very good. So, but this is very simple. Mathematical explanation is very simple. See, mathematical expression, that of A, B, C, D. So the alternate will be there is difference. There is difference means not equal to. Oh God, matching. That A not equal to that B not equal to that C not equal to that. Okay, you're done. So now what we do is let us take some data for this. We already have some sigma level calculator. Please note whenever your y variable is continuous, that is measured value, and your x variable exists in 2 or more levels, you need to go for ANOVA. Actually, Oh, password. Password is given. So this is the file I want. In this, the turnaround time data is available. It's here, lab that. What we need to do, we just have to copy. Let's copy this data. You see here, lab 1, lab 2, lab 3, lab 4, shift control down, copy. Copy everything. Now, we just go to Minitab. Place our cursor on the gray row and paste it. Now we got all the data, lab 1, 2, 3, 4 on the Minitab worksheet. Now imagine, now see here, you have to click Start, go to ANOVA, go to one-way ANOVA. Start, ANOVA, and one-way ANOVA. I click that. Now this window is coming. Now what is this saying? Response data are in one column or in separate column. Tell me which option suits our data. Response data in separate column. Can you see the
Separate column.
response data in four? Then you click your cursor here. Now responses, where are the responses? Here. 1, 2, 3, 4. You select everything, click select. Now you go to option. Confidence level. Confidence level how much? 95%. What is the interval you want to use? If you feel only one side the limit is sensitive, then you should choose upper bound or lower bound. And in this case, both sides are sensitive, so take both sides. And you have to tick this thing. What is there here? Assume equal variance. Always while doing ANOVA, variances must be equal. So I tick this. I give OK. I give one more OK. Now the analysis is done. And the interval plot, Minitab has generated the interval plot for me. Look here, all of you. Can you see the I section for lab 1, I section for lab 2, I section for lab 3, I section for lab 4? What is this I section? This is the average of lab 1. What is this one? Can you see what is this interval? It is written here, 95% confidence interval for mean. This is the upper limit and this is the lower limit. Okay. Lower limit is 175, upper limit is 181. Now, same manner, you have average for all the 4 lab. Now, please tell me, do you think any particular lab is consuming, more turnaround time for performing a particular test? Or is there any particular lab that consumes lesser time? Looking at the graph, are you able to come to a conclusion?
Lab 3
Lab
is having
3 and lab 4.
Correct. The laboratory 3 is found to consume more time than 1, 2, and 4. And laboratory 4 is found to consume lesser time in comparison to remaining 3. Can I announce this? Can I announce this finding? Can I proceed with some action based on this? Yes, definitely you can proceed, because if I try to move this mean, I could see the mean left and right not actually intersecting with the interval of any of the other labs. Are you getting my statement? When I move the mean left or right, the movement doesn't intersect with the any of the other confidence interval. Is my statement correct or not? Come on, yeah, please say yes or no. When I move the mean leftwards or rightwards, I see the mean completely above the confidence interval of all the other 3 labs. Is my statement correct or not?
Yes.
Yes, sir.
This is called statistical significance. This is called statistical significance. That means laboratory 3 is found to have a statistically or significantly higher TAT than other labs. Another statement. Laboratory 4 has significantly lower TAT than other labs. Now, now as a chief of the hospital, what would you like to do? Would you like to do? You like to take some action on lab 3, or you would like to take some action for lab 4? I don't know. Whatever is possible, yes, you can take. Lab 3, maybe some penalty or something, some fine. Or lab 4, some rewards. Or you want to be lenient? Yes, laboratory 3 can be put under some training. Even 1 and 2, when I compare with 4, they are taking more time. Is my statement correct? 1 and 2, when I compare to 4, they are taking more time. Is my statement correct or not? Because when I move their mean, the mean is completely above the maintained by whole interval maintained by laboratory 4. Whenever if someone is able to perform, in a way that in the entire interval, if your average is above, then you are considered to have a significantly better performance. So in this case, the factor laboratory is significant to turnaround time. If you are looking for a higher turnaround time, then you have to be choosy with the lab. If you are looking for a lower turnaround time, then also you have to be choosy, right? Because the factor lab has a significant effect. If you think all the 4 labs will give a same experience, then you will certainly have a disappointment or dissatisfaction. So this test is known as ANOVA. This test is known as what? ANOVA. Yeah. I'll tell you when to exactly go for ANOVA. You go for ANOVA whenever your y variable is continuous. See here, written here. Y variable is continuous and your x variable is discrete with 2 or more levels. Whenever y variable is continuous and the x variable is discrete, or sometimes we call them attribute also, with 2 or more levels. Now in the laboratory, how many levels we considered? How many labs? 4 labs. So there are 4 labs. You all understand why it is ANOVA? Yes. Now inside the session window, this is called ANOVA table. You see, this is called ANOVA. In the ANOVA table, the criticality of the factor can be compared using p-value. All of you, can you see p-value? All of you, can you see the p-value? Tell me. P-value is less than 0.05. If p-value is less than 0.05, then the option is reject the null hypothesis. Reject the null hypothesis means the factor is critical. Whenever you are able to reject the null hypothesis, the factor is critical. Critical means the factor has an effect. The factor is one of the root cause. The main reason for the delay in the turnaround time is the laboratory selected. Now all of you, please tell me, once you understand the laboratory, the laboratories have significant difference in the turnaround time. When you want to give some testing done, definitely you have to choose the lab and then give the test. Yes or no? Otherwise, you have to wait a longer time. Are you getting my point, all of you? So this test is known as what? One-way ANOVA or ANOVA test. Come on, please get your doubts clarified. Are there any questions here while doing ANOVA?
Some more different example if we have, then we have more clarity.
Yeah, that will come, don't worry. But any questions now at this stage?
So this percentage of error, it will be always 5%, or it's how we decide it, the percentage of this error, 5% or 10%.
Correct, very good. It's a normal industry practice unless otherwise specified. The level of significance or the alpha risk, whatever we call it, is fixed at 5% only. But certain industries, they might reduce, like healthcare, or some kind of industries where they can't even afford 5% of sampling risk. For them, they change the, what do you call, the alpha to 1%. If they reduce the alpha to 1%, then confidence level will become what? Confidence level will become 95%. Confidence level and alpha risk, if we have, if we sum up, it will come to 100%. Now another case. Now I will share the screen again. We'll do another case. I copied this cutlet diameter file from here. I'm going to Minitab, going to the worksheet, then I'm pasting here. Now what do you see? Cutlet A, cutlet B. Cutlet A, cutlet B. Now, meaning you have two machines. What is your output Y variable here? What is the Y variable? Cutlet diameter. Cutlet diameter. What is your X variable here?
Machine.
Very good. Machine A and machine B. That means the X factor is understood. How many levels the X factor exists? Level is 2.
2.
Please note, whenever the level is 2 or more, the hypothesis test recommended is ANOVA only. Any number of level, 2, 3, 4, 5. Let us say you are dealing with 5 suppliers. You are dealing with 5 suppliers and the quality of the supplied material is measured in some kind of measurable characteristics. Let us say some surface finish or something. Now, when you deal with 5 suppliers, you want to find out whether any particular gives the supply the material with a better surface finish. This is the question. Now, which hypothesis test is recommended? Again, ANOVA. So this case also, cutlet diameter, 2 machines. Now your doubt is whether the diameter is dependent on machine type or not. When I have 2 machine A and B, whether the difference in the diameter is caused by the selection of the machine or not. That is my question. So can I take up this as ANOVA again, all of you? Whenever the level is 2 or more, you can go for ANOVA. But when the level is 2, you also have another option to solve the same problem using 2 sample t-test. When will you go for 2 sample t-test? When the X factor level is 2. But definitely for more than 2, you have to go for ANOVA. But if the level is 2, instead of 2 sample t-test, you can also do an ANOVA. So now what I'm going to do is, I'm going to solve this cutlet diameter problem also using ANOVA only. You see, stat ANOVA, one-way ANOVA. Now response data are in separate column. Yes, we have them in separate column. One is cutlet A, click select. The other one is cutlet B, click select. Go to the option 95% confidence level, two-sided, assume equal variance. Okay. Again, one more okay. Now look at the interval plot and tell me. When I move this mean, is it going without intersecting the confidence interval of the other cutlet?
No.
No. That means statistically there is no difference. There is no significance. That is called, there is no significance. Instead of looking at the graph every time, the alternate way you can do is you can look at the p-value. For that, you just have to go to the session window. So go to the session. You come here, ANOVA table. Under the factor, what is the p-value? Tell me.
0.47.
P-value is more than 0.05, which means fail to reject the null. What do we mean by fail to reject the null? Fail to reject the null is machine type is not critical. Machine type is not the root cause for variation in the diameter. Do you understand? Machine type is not actually critical. The fact the suspect is wrong. Do you understand, all of you? What is this test called? And again, this again, one-way ANOVA. Any doubts, questions?
Sir,
Or you have any?
could you please, sir, could you please explain that fail to reject the null? Actually, difficult to digest that word. What is exactly it means?
Fail to reject null. Actually, practically it means accept the null, isn't it?
Okay.
See, let us say there is a suspect. There is a suspect, right? In judicial system, the suspect is initially called what? Innocent. And if the crime is proved, he is called
Accused.
criminal. Accused. Okay, accused. And now, initially, the judge will assume that he is innocent, right?
Okay.
But as the evidences favor, the judge will slowly reject innocence. Yes or no?
Yeah, yes, sir.
This is called reject the null hypothesis. Reject the null hypothesis means the belief of innocence is wrong. The belief of or the assumption of innocence is wrong. That means he is now, he can now be declared as accused. Is it clear, all of you? Or suppose if evidences are not sufficient, the judge will stay with this decision, fail to reject, or otherwise fail to reject the innocence. Because so many evidences produced, but none of them is convincing. Now the judge will stick on to calling the suspect as what? Innocent only. Correct or not? So you can, in statistics, there are only two possibilities. Either you can reject null or you can fail to reject null. Fail to reject null practically means what? You just continue with the innocence. The factor is not critical. If the factor is not critical, you no need to take any change. See, all of you, please note, when you after performing hypothesis testing, what are you doing? You are actually changing the process, isn't it? You are making changes in the process, isn't it? Ultimate idea is you are making changes. But before making the changes in the process, you are checking whether the factor is actually root cause or not. So the important rule we must follow is while making the changes in the process, whether your changes improves the result or not, your changes should never destroy the existing result. Is it important or not? When you are making changes, whether the changes leads to the improvement or not, it should never destroy the existing result. And that is why we make the changes in the process only if we are able to reject the null hypothesis. If we could reject the innocence, then only we make changes in the process. So this is the important condition to be fulfilled. Otherwise, what happens? It will be, no company will like, your frequent, what do you call, decision of making changes and then destroying the existing result. No company would like. So, the rejecting a null hypothesis when it is actually true is known as type 1 error. Is known as type 1 error. So the type 1 error, should be limited to 5% always in decision making. The type 1 error must be limited to 5%. And that is why we used 95% confidence level. That is why we used an alpha value of 5%. And that is why the p value is compared against alpha. P value is always compared against alpha value. Alpha value is 5% and p value is position of your statistics with respect to the confidence limit. So based on the p value, you can make decision. Hope your question is answered, right?
Yeah, yes, sir.
Correct. So hereafter, when you are writing, don't say accept the null. You need to say fail to reject the null. Instead of saying accept the null, what we need to say? Fail to reject the null. That is why it comes. Always in research, in all those things. Why are we, very carefully, choosing the words? Because we only did a sample study. Please understand. Only we have a lot of constraints while conducting the study. So to ensure, there are constraints, used in the study, we carefully use the word fail to reject the null. Okay, any other questions? Or anybody would like to discuss any of your, cases, real cases? We can take up the, hypothesis testing here. Now please tell me, all of you. Are you seeing my Excel sheet? There are cab agents A and B. Can you see cab agent A and B?
Yes,
Every
sir.
time a cab is booked,
Yes, sir.
cab A, they respond or they send the cab within this many times. This many minutes. Cab B, they take, this much time. Now you have to find out whether cab A and cab B, are they performing at equal level or is there a difference exists between A and B? What do you think, all of you? By looking at the data at the first level, I'm going to Minitab. I'm opening the worksheet. I'm just pasting the cab data. You see. Now, what do you think, all of you? Cab A is good or cab B is good? Who is faster?
Cab B is
A.
faster.
B.
Now, let us understand what statistics is telling, right? So, now how to write the null hypothesis for this case? Come on. The cab arrival time. Cab arrival time for A is equal to the arrival time for B. Okay? How much time
Yes.
the cab takes to reach the place, right? We call it, arrival time. Now the alternate will be H0, so I'm sorry. H0. So the H1 will be, I just have to change, not equal to. Okay. Now as usual, unless otherwise declared, alpha will be how much? 0.05. Now what is the test I should do? What is the test here? What is the recommended test? Please note your y variable is continuous. Am I right?
Yes.
Yes.
Minutes. This is minutes continuous. X variable. What is X variable in this case? The cab agent.
Discrete cab A, cab B, cab agent.
Yes, you are right. It is discrete. And the exact thing is, what do you call? The cab agent. How many cab agents are available? Levels?
2.
2. Now, the exact test you can do is, either you can do ANOVA, since
One way.
the level is only 2, you can also go for 2 sample test. Anyone, both are same. Are you with me, all of you? Now, shall
Yes.
I do the test for you? I go to the worksheet and I have the cab A and B. Stat. You guide me, all of you. You guide me. I should click stat, right? After that,
ANOVA.
ANOVA.
then,
One way.
One way.
One
One
way.
way.
wow, very good. One way, stat, ANOVA, one way. Then this window is coming. Your response data in separate column or in one column?
Yes,
Separate column.
Separate column. Now remove existing
Yes.
one. Now cab A and cab B both should be selected and select. Now you should go to option. Confidence
Yes.
level normally generally 95%. And
Yeah,
we want to
two-sided.
test, two-sided and assume
Yeah.
equal variance. You make sure this is tick. Now you give okay, give one more okay, and look at your cab agent performance. Now come to a conclusion, all of you. What do you think? Cab agent A and B. You said, somebody said B is faster. But ANOVA, what ANOVA is telling?
Both
Both
the
are
Same.
Anova is telling there is no difference.
difference.
That means you are not supposed to differentiate the performance of cab A and cab B statistically. Mathematically, there could be some difference, 1 or 2 minutes. But statistically, practically, no, we don't want to differentiate them. That means we want to continue the contract with both agents for maybe another tenure. Do you understand? Because we really don't see significant difference in the performance. All of it you understand. So you can look at the graph which is known as interval plot and take a decision, or in terms of p value you can take a decision. You see here. Look at the p value, how much?
0.976.
0.9 is too high.
Greater than.
So p value has to go below 0.05. So according to the data, there is no difference in the cab arrival time between agent A and agent B. You might be dealing with two suppliers, you might be dealing with two departments, you might be dealing with two factories, or you might be dealing with two of your team members. All of them are cases of ANOVA or cases of two sample t test. Are you with me on this? Are you with
Yes.
me? Yes or no? Yeah.
Yes.
Now I want to group all of you into two categories. Those who attend the session with with the camera on, with there is a good confidence, and then you some people set of people who attend the session on camera, another set of people who attend the session with the camera off. Now my claim is keeping the camera on can boost your learning. Is my claim correct or not?
Yes, correct.
We need to
Yes, sir.
subject it to hypothesis testing. So null hypothesis will say whether you keep the camera on or off, it is going to be same. That is why majority of participants, they are not on the camera here. You can see and you can understand now. This is the null hypothesis. Now we have to prove them wrong. Yes or no? We have to prove them wrong. In order to prove them wrong, the statistical step is reject the null hypothesis. What should we do? Let's say a set of 10 people who attended the session on the camera is considered. Another 10 people off the camera is considered. And after the session, we conduct an exam. After the session, we conduct an exam. And one set, you have marks scored by students who attended on the camera. Another set, marks scored by the students who attended off the camera. There will be an average on the left, average on the right. Am I right? With the camera, there is an average. Without camera, there is an average. And there will also be confidence limits. You have to compare whether the confidence interval are same. If they are same, if they are overlapping, then there is no difference. If there is no overlapping, straight away there is a difference, you see. The people who attended the sessions on camera, they all scored very high marks. Their interval is very high compared to the other thing. I don't see any intersection happening. Can you see that? The I section. If no intersection happens, what will be your conclusion? Attending the sessions on the camera is definitely boosting your learnings. And hence, that reflects in your marks. Do you understand, all of you? So next meeting onwards, all your meetings should be camera on meetings. If you come to this conclusion. Is it correct? Is it a case of ANOVA? It's a case of ANOVA. It is also a case of two sample t-test. What will I do? The same problem cab agent, I want to do it as a case of two sample t-test. Shall I do it? See here, cab agent A, B. Similarly, cutlet A, B. This is also a case of two sample t-test, but this is definitely a case of ANOVA only because more than 2. But when I compare 1 and 2, what is this called? This is also a case of what? What is this case? Comparing 1 and 2?
ANOVA
Two
only.
sample t-test. Now, two sample t-test or ANOVA. Wherever two sample t-test you can do, you can certainly do ANOVA. Now, let me do the two sample t-test per cap. See here, stat, basic stat, two sample t-test. You can read the description. Determine whether the mean differ significantly between two groups. So, two sample T. Now, both sample in one column? No. Both sample in each sample in its own column. Sample 1 is cab agent A. Sample 2 is cab agent B. Option confidence interval 95%. The difference in the mean is 0, not equal to, hypothesis difference is not equal to. This is your alternate. Assume equal variance. Assume equal variance. Okay. One more. Okay. Now, when you do the two sample t-test, interval plot will not come, but p-value has come. Can you see the same p-value has come here also? Are you noticing? What is your
Yes, sir.
conclusion when you notice a higher p-value? What is your conclusion?
Fail to
What is your
reject.
conclusion?
Fail to reject H.
Fail to reject null. That means what? There is no difference in the cab arrival time. Whether you book the cab with the agent A or agent B, they both will be arriving sending the cab more or less same time only. Not much difference. Not much in the sense statistically there is no difference. Hope you all understand this. Now please guide me. If I have to handle the cutlet case with the two sample t-test, where should I click?
Stat.
Come on, tell me.
Stat.
Stat.
Basic
Basic
stat.
stat. Then
To sample test.
Yeah, two sample. Two sample.
T.
sample t-test. So you click that. Each sample in its own column. Cab A, you remove. Go to cutlet A.
Cutlet A.
Cab B, you remove. Cutlet B.
Cutlet B.
Go to option. Just like last time, you give everything not equal to. Everything is correct.
It's correct. Assume equal variance.
Okay, okay, and one more okay. Look at the p-value. P-value is how much? 0.472. 0.472 is more than 0.05. You have to be very careful, all of you. You should not, get confused. Since p-value is more than 0.05, fail to reject null. That means there is no difference in the cutlet diameter produced by two machines. Whether you use machine 1 and machine 2, the diameter is going to be same. Statistically same. That is the meaning. Clear, all of you?
Yes.
Now, laboratory 1 and 2. Is there a difference between the laboratory 1 and 2? Stat. Basic stat. Two sample T. Each sample in the one column.
Lab 1.
Lab 1. This must be very good. Option. Everything you just check. Everything is fine.
Okay.
So two sample t-test is done. Look at the p-value 0.76. 0.76 is more than 0.05. Please understand. 0.76 is more than 5%. More than 5% means fail to reject. Whenever you are not able to reject the null, you cannot declare the factor as critical or significant or root cause. Come on.
Could we just check lab 2 and lab 3 instead of lab 1 and lab 2?
Oh, you want to check 2 and 3? Yeah, okay, we can check. Stat. Basic stat. Or when we do it in ANOVA, we get the graph also. One way ANOVA. Response data on separate column. We want to compare 2 and 3. Option as usual. Now tell me 2 and 3, what I do? Do you see any difference?
Yes.
Is there a difference? Yeah,
Yes.
big difference. Statistical difference is there. Statistical significance is there. The same thing will be confirmed using p-value also. You look at the p-value. What is the p-value?
0.
0.
0 means very close to 0. That is the point, right? So what we want is a p-value less than 0.05. So p-value less than 0.05 confirms we need to reject the null. So a difference exists between 2 and 3. Clear, all of you?
Yes, yes.
Yes, sir.
Now, for any laboratory to set up, their what do you call their lab in my hospital, the requirement is the TAT of the test. The TAT of the test should be, let us say, less than or equal to 175 minutes. Now we have to check whether any particular lab is eligible to qualify for setting up their facility in our hospital. Shall we try this? Now we have to try this one by one laboratory. One by one. What is the requirement? The TAT must be less than or equal to 175 minutes. Am I right?
Yeah.
See here. Null hypothesis. TAT less than or equal to. The moment equal to comes, it is null. Then what is alternate? TAT more than 175. Now, how many labs we have? Lab is we have 1, 2, 3, and 4. That means what? The level is 4. Now, this is definitely a case of ANOVA. Let's do the ANOVA. Stat. Sorry, this is 1 minute. So now we want to test the thing against the reference value. Yeah, against reference value. First thing we'll do it for lab 1. Lab 1 versus a reference value. This is actually one sample t-test. So similarly for lab 2, another one sample t-test. One sample t-test, you have to do it 4 times to come to a conclusion whether any particular lab meets the for hospital norm of turnaround time less than or equal to 175 minutes. Now you see, I'm going to do one sample t-test. Stat, basic stat. Sorry, stat, basic stat. All of you, are you seeing one sample T? Terida, can you read the description?
Yes, sir.
Determine whether the mean of the sample differs significantly from a specified value.
Specified value is how much?
175.
175.
175.
Yeah. So you click that, this window will come. One or more sample in a column. Yes, we have the data in a column. Where is that column? Laboratory 1. Laboratory 1. Perform the hypothesis test. Hypothesis mean is how much? 175. If you check a sample against a reference value, the test is called one sample t-test. Going to option, all other things are same. 95% not equal to okay. One more okay. The one sample t-test is done. Now what is the p-value?
0.006.
That means what? P-value is less than 0.05. So we have to
Reject.
reject the null. Reject the null actually means what? Actually means what?
That is
Right to reject.
There is significant
difference is
difference. There is a significant difference between the mean turnaround time and reference turnaround time. Now let us look at the mean turnaround time. How much it is? 178. How much is permissible? Only 175 is permissible, isn't it? So the mean is on the higher side. So reject the hypothesis. What is your null hypothesis? The laboratory is found to have a TAT lower than 175, which is wrong. That is getting rejected. So now you should not be allowing the lab 1 to have a setup in your hospital. Is it clear, all of you?
Yes, understood.
Yes, understood.
Now we can do it for lab 2 also. Stat, basic stat. Again, one sample T. But this time instead of 1, we try with 2. Okay. Now again, this time p value is less than 0.05. Here also the mean is 178. 2 also not eligible. Stat, basic stat, one sample T. Instead of 2, let's go for 3. Now p value is less. Oh God, they are having a mean value too much, 199. They are on the higher side. They are also not eligible. I think none of them, maybe 4 might come. Basic stat, one sample T. Laboratory 4 option. Everything is good. Look at the p value. Look at the p-value is less. At the same time, look at the mean TAT. Now, who is more reliable? Which laboratory can be allowed to set up their facility inside the hospital? 1 or 2 or 3 or 4? Come on, tell me.
4.
Which lab?
4.
4. 4 you
4.
can definitely confidently allow.
4,
Because
sir,
p-value
4.
is also less than 0.05. Your requirement is also met. Please note, all of you, the findings from the data will be considered reliable only when the associated p-value is less than 0.05. If the associated p-value is more than 0.05, then the risk is very high. Under such conditions, believing the data is, can be harmful. Do you understand, all of you? Now, what are the hypothesis tests we discussed? One way ANOVA. Man, why you are not responding, all of you? What are the hypothesis testing we finished? One way ANOVA.
2 sample.
One
Two
sample
sample
T.
t-test.
When we have
And
2 or more than 2 sample.
Correct. Very good. Now, now let us do one more example. See here, painting method, dipping painting method is there, spraying painting method is there. Dipping, spraying, dipping, spraying, dipping, spraying. The right side is adhesive strength. I copy this data. Go to mini tab. Go to worksheet. Now I paste the data here. Painting method, how many painting method?
2.
Only 2 method, dipping, spraying, dipping, spraying. And adhesive strength is a measured value. Now, since the factor exists at 2 level, I can either go for 2 sample t-test or I can go for one way ANOVA. I know you all agree with me, one way ANOVA is advantageous because it gives the interval plot also. Stat ANOVA, one way ANOVA. So this has come. Response data in separate column. No. In this case, only one column. What is the response? Adhesive strength is the response. What is the factor? Painting method is the factor. Option. 95%, two-sided, equal variance, okay. One more, okay. Now you have to answer me. Please answer me. Are there, is the painting method is significant to the adhesive strength or insignificant?
Significant.
Yes. That is again evident with the p-value. See, if you see, your analysis will be more reliable if the associated p-value is less than 0.05. Clear, all of you? This is done. Now, how to do this in Excel? How to do this in Excel? Shall we do ANOVA in Excel, all of you? Pranlama?
Yes,
we can do.
yes, sir.
Yes.
I'll tell you. In order to do ANOVA in Excel, you have to go to data, click data. There is a data analysis. If this is not appearing, first you have to make it appear. You have to go to file. You have to go to option. File, option. Then this window will come. You have to come to add-ins. Come to add-ins. Add-ins. Then come to manage Excel add-in. Go. Do you see the analysis tool pick tick mark? If I remove the tick
Yes,
mark,
sir.
this will go away. For right now, I want it. I put tick mark. I give OK. Now the data analysis has come. All of you, can you also check and let me know whether you are also able to create the data analysis pack? Using the data analysis pack, you can conduct ANOVA. Okay. So now go to data. Go to data analysis. The moment you click data analysis, can you see the first one? What is first one? ANOVA.
ANOVA single factor. ANOVA single
Yeah,
factor.
ANOVA single factor. Click. Where is the input range? The input range is painting method, analysis strength. Selected. You have label in the first row? Yes. Label columns have been, titled. So label in the first row. Alpha 5%. Where do you want the output of ANOVA? I want the output of ANOVA here itself. Yeah, where already there is a cursor, right? Okay. Sorry, output range. I have to click here so that I will be able to come and click. See here, this is this in this area I want the output. So I give OK. Oh God, non-numeric data. I'll just come. Oh, painting method. This. I need to do it one more time. Analysis, single factor. Oh, input range. Input range is painting method. Adhesive strength. Label in first row. Output somewhere here.
Sir,
Why it is coming?
can you select without title?
Not without title, I think. Adhesive strength. Go group by column. Oh. Mhm. We have to restructure the column, I believe. Correct. I understand. Now I will do this. I'll go to the one that has the proper format. Cancel. Maybe the lab tat will go. This can also be do. We just have to modify the data. I didn't realize. This one. See here, lab data, lab tat. 4 labs are available. Data analysis, single factor ANOVA. Now let's select the data here. 1, 2, 3, 4, shift control down. I selected all the data, right? Now label in first row, alpha output range. Where do you want the output? Where do you want the output? Wherever you want, you can just choose place. Let me go to the bottom. Let me get the output here. I place the cursor. Now I give OK. Nache. Okay, override existing data. Let it write, not a problem. Can you see ANOVA result coming, all of you? Just below the data I put, ANOVA result has come. Now what is important is you have to look for the p-value. Tell me, look at the p-value and tell me how much it is. How much is the p-value? Less than 0.05 or more than 0.05?
More
Less
than
than
value.
0.05. This is such a small number. E to the power of minus 57 is such a small number, less than 0.05, also you reject the null. So whatever we did in using a Minitab, we are able to do it in Excel also. Clear? But here the point is, you have to arrange the data in this manner. How? The factor must appear in row number 1. See here, factor. Lab 1, lab 2, lab 3, lab 4. Here, this is a factor name should appear as the column label. And the exact value should appear as your Y variable. So we can also modify, the painting method and adhesive strength in this manner, and then we'll be able to do it. Now, shall I do 2 sample t-test between lab 1 and lab 2? Using Excel?
Yes.
Yes, we can. Data analysis. Now t-test, two sample assuming equal variance. Variable 1, lab 1 from shift control down. Variable 2. Shift control down. Variables are given. Label is given in the variable, yes. Alpha 0.05. Where do you want the output? I want the output below the data, let us say. Here. Column. Okay. I think here also overwriting might happen. Let it happen. Now this has come. Can you see all of you? Can you also see the p-value? Can you see the p-value?
0.338.
0.3. That means more than 0.05. More than 0.05 means there is no difference in the lab 2 and 3. Yeah. Whatever we did. What we did, actually 2 and 3 only we did, right? Sorry. What? 1 and 2. We did 1 and 2. Now, so 2 sample t-test we are able to do. ANOVA we are able to do in Minitab. Now tell me, do you have any there? Now, have you understood this procedure, all of you?
Yes.
ANOVA, 2 sample t-test. And in fact, there is one more thing. 1 sample t-test is also there. 1 sample t-test. When in order to go for a 1 sample t-test, you should be comparing your sample data against what? A reference value. Against a reference value. So please tell me, any questions? Anybody would like to ask any question on this, on the topic so far? All right. Now let us take this example, the last one more eyebrows test. See, a company manufacturing cooking oil, they claim that their cooking oil bottle have less than 15% fat content. What is the company's claim? Fat content is
15.
less than or equal to 15%. Can you
Less
see
than
my cursor?
15%. Yeah.
Can you see my
Yes, sir.
cursor on the null hypothesis?
Yeah.
Yes, sir.
Yeah. Null fat content less than or equal to 15%. That is your null. Then what will be your alternate? Fat content more than 15%. That is your alternate, right? And this is a right-tailed test. All of you please know. Now let us do this right-tailed test in Minitab. There are about 13 samples available. I'm copying everything. I'm going to Minitab. Place my cursor on the gray row. I have the fat content also available. Now what is the test we should be doing? One sample t-test. So go to stat, basic stat, then one sample t. Stat, basic stat, one sample t. Click. One or more sample in a column. Yes, in a column. Where is that column? Where is that column? Column 15. Click and select. Perform hypothesis test. What is the declared fat content? Up to what percentage fat content is permissible? 15.
15.
So that's a reference value that is typed here. Go to option 95%. Now the required alternate will be more than. Now you are based on the test, you are going to check whether the fat content is less than 15% or not. If it is less than 15%, then people you can buy the cooking oil. Okay. One more okay. P value is less than 0.05. Can you see all of you? P value less than 0.05, but your observation is outside the interval. Can you see that? 16.6. 15 up to 15%, is what is, permissible. But your mean is found to be at the 16.6. That too with the statistical significance. So it should not be taken lightly. Now, what is your understanding about the company's cooking oil? It is not fit for recommendation. It is not fit for recommendation. So this is known as one sample t-test. So what are the tests we did? We discussed one
One
sample
way,
t-test,
two
then
sample,
then one way.
one way.
So what one common thing what we noticed is all of them are coming under the family of hypothesis test known as test of averages. All of them are coming under test of averages. So test of averages means continuous data. Now let's utilize this time, the rest of the time, for discussing, some real scenario. Now, anybody dealing with the multiple suppliers? Anybody are you dealing with multiple supplier?
Yeah, yes, sir. I am handling.
Okay. What is the criteria you would like to know? Compare them. When you compare your multiple supplier, let's say you are procuring, some alloy. Alloy composition you are checking whether the alumina content is correct or not. And how many
Okay.
supplier you maintain? How many supplier you maintain?
Yeah, we may take 5 suppliers, for example.
Okay, 5 suppliers. And let us say you are buying the ingot only. In the ingot, important property is alumina, yes, alloy content or alumina content. Alumina content is measurable. That is your Y variable.
Yeah, yes, sir.
And X factor is nothing but what? Supplier. The level of X factor is 5 because you are dealing with 5 suppliers.
Yes.
So this is actually helping you to understand that the analysis required is one-way ANOVA. The analysis required is one-way ANOVA. And if you want to do one-way ANOVA, you have to just type down the the data. Type down the data in separate column. Then we will be able to analyze it with the help of one sample t-test is. One sample t-test is whether the cooking oil supplied by the company is having below 15% or above 15%. This is what exactly performed for what is the chips name? Potato chips. Lay's chips. Lay's chips was banned, Similar test only carried out that time, known as one sample t-test. All that they decided they wanted to conclude that the Maggie packet should be recalled and destroyed is the the uh, p value only. They just did the one sample t test and found the p value, and the lead content is found to be on the higher side. Here we are saying fat content, and lead's was yes, they know is it Lays? Yeah, not Lays. Sorry, noodles, Maggie noodles, Maggie. Maggie was banned mainly for what? For what? Lead content. Maggie was banned mainly for lead content, and the lead content were found to be beyond the reference value. Whenever you have a reference value and compare a sample against the reference value, that should be one sample t-test. So there is one sample t-test, there is two sample t-test, there is one-way ANOVA. And wherever two sample t-test can be performed, we can also perform ANOVA. How many of you agree that the statement is true? Can I do ANOVA in all places of two sample t-test?
Yes.
Yes, panla. Yes, the answer is yes. So, but once the number of factor level increases above 2, then ANOVA only is option available. Now tell me, any further doubts, any questions?
Can we apply this ANOVA or the t-test for the training versus training means new people in the machines versus output impact, right? For example, there are multiple operators. Our
Very
output
good.
is
New people means newly recruited operators, huh?
yes.
Newly
Maybe they are
recruited
60 days,
operators against experienced operators.
60 days old, 30 days old. They're less than 1 year old, for example.
Okay. If you have 3, 4 groups of operator, then what is that you measure against each one of them? Their productivity, yeah?
One is the output, another could be we can measure on the rejections also.
Okay. Rejection is a counter data, and output is also a counter data. But the time
Okay.
required to make 100 parts, that is a continuous data. Do you understand? Time required to make 100 parts is a continuous data. If you talk like
Okay.
time required for 100 parts, then you should go for ANOVA. If you talk like
Okay.
number produced or number rejected, then it should probably change to a family of tests known as test of proportions. A family of tests known as test of proportion, which I will we will discuss again when we come to the
Okay.
analysis phase one more time. Good question.
So basically
There anything
the
else
right
anybody
way
would
is
like to?
right way to use is the output per hour like that, right?
Time required to produce 100 numbers. If you
Okay.
measure that way, then it will be coming under ANOVA. But nothing wrong. Your thinking is also correct, but you have to go for chi-square test. We'll be learning it.
Okay. Thank you.
Yeah. Anybody would like to share the screen and do the Minitab like how I did? I want to see your proficiency in Minitab. Anybody ready? Or nobody is interested in transforming, yourself? Come on, it's easy.
Sir, could you please share the data, some data in chat so we can paste?
Yeah, that Excel file calculator, it was not there with you.
No.
Why?
No, where we have to take?
It is shared in the Minitab.
Recording in progress.
I'm sharing again here. But I have to close the file. Nachi. So I've shared here in the chat box. You can download. If you are in a laptop, you can easily download and do it. Sigma 11 tablet. And tell me, you want to compare, the what do you call the cycle time of producing a part from 3 different machines. Whether a difference in the cycle time exists while producing the same part from 3 different machines. What is the test required now? Whether the part produced using 3 machines has different cycle time or not.
No.
ANOVA. One way ANOVA. What is the null hypothesis here?
No
Cycle
difference.
time.
No
There is
difference.
no difference in the cycle time. There is no difference in the cycle time. Alternate hypothesis will be there is a significant difference in the cycle time. And the test alpha is 5%. Test is one way ANOVA. And when we do the one way ANOVA, depending on the p value, you can take a call. If p value is less than 5%, what will be your conclusion?
It is
If P
significant.
value is less than 5%, what will be your conclusion?
Cycle time variation is there.
Cycle time variation is there because of the machines. Reject the null hypothesis. And no, the machine is critical. Machine is significant. Done. So any other doubt? Anything you want to ask? Something you want to learn from me? Come on.
Sir, have you shared that data so we can practice, right?
Yeah, it is there in the Excel. No, see Excel right now in the chat box I just uploaded. Can
It
you
is
see in the chat?
protected, sir. It is asking password.
Asking for a password.
GSK.
Password also is wait. Yeah, that's what the file is shared already. Password is GSK.
Sir, I got disconnected and joined again. I am unable to see any messages in the chat. Only password what you have sent now. That's only visible for me.
Now I have to upload again. Now you will be able to see.
Yeah. Now I got it, sir. Thank you.
See the procedure, if you remember, and also all the explanation no, we discussed today. If you could remember and then do some self-learning on your own, you will become an expert in the hypothesis test-based decision making. Okay, who is going to do it?
Sir,
Who is going to...
shall I proceed, sir? Abhiram.
Yeah, try, ma'am. You can. So you
we'll
can
check.
share the screen. Wait 1 minute. I have to give enable waiting room lock meeting participant. The share option is available for you.
Yes, sir. Try.
Yeah, if screen sharing is available, please share.
Yeah. Yes, sir. Can you able to
Very
view
good.
my screen? Yeah, it is my
Perfect.
own sample.
Oh, very good. One sample. Then we can learn from it. 1 minute.
Yeah. I have just tried.
What is this? What is this? Cap 1,
This
cap 2?
cap and cap.
It says this
Just provided the
our
random
case.
number.
Okay.
Just want to replicate, sir. So.
Okay. Oh, you got some results immediately.
Yes, I tried once.
Excellent.
So I have selected both the caps and stat.
No, in Minitab, you don't have to select like this. Yeah, stat, ANOVA, 1V ANOVA. Yes, correct. Click.
Yeah,
Now response data are in separate column. Yes. And then you have to
Can I deselect and select, sir?
responses. Yeah, you can delete and
Previously
select. No? Delete and select. Yeah, you can select here now. Double click or you can select. Yeah, option.
Options. 95.
95 equal variance, two-sided. Very good. Okay. And one more. Okay.
So I got the
There is no
result.
difference. There is no difference. What will be the p-value here? In this case, p-value will be more than 5%. If you want, you can go and see. Yeah. Go up, p-value. And see, 0.328. Very good. The same problem can also be solved using two sample retest.
Can I try, sir?
Can you solve it? Do it using two sample retest. Stat. Basic stat, two sample T.
Sample.
Both sample in one column, no, separate column.
Different.
One column, yeah. One column, next.
Column. Okay.
Sample 1, C1. Sample 2, C2. Option.
Options.
Give appropriate values. Confidence level 95. No difference. Assume equal variance. Okay. One more okay. Look at the p-value. Same 0.328.
Yes, sir.
That means fail to reject the null.
Fail to reject. Greater than 0.5.
Can you do the two sample t-test or ANOVA in Excel also?
Yes, sir.
Just to open the Excel file, yeah. Is
The
your data
data
analysis available?
already enabled, yeah,
Data.
enable data analysis. Data analysis.
Click the data analysis. Just click on that data analysis top.
Okay.
Now you can first do it with ANOVA, single factor ANOVA.
Okay. Input range. Here I have to select
range,
right, sir.
Yeah, both cap 1, cap 2. Yeah, this is the method you should keep the data. The level wise you have to keep the data. Now this is correct format. Yeah. And then label, you click the label, label in first row. Then come to output range.
Yes,
Place
sir.
your cursor inside. The output range box. Now select somewhere outside here.
Here.
Outside, right side, anywhere in free area. Place your cursor there. Yes, D1 is okay, or D2. Right, okay, that's all.
Shall I click this, sir?
Click that. Now you give okay. That's all. Okay, I'm getting you. That's all. Your work is done. Now you did ANOVA using Excel. Now do the two sample t-test using Excel for the same problem. No need to select now data. First you click data analysis. First.
ANOVA two factor.
No. Go to two sample t-test. Come down. T-test with equal variance. T-test next. Two sample t-test with equal variance. Okay. Now variable one is cap 1. Okay. Variable 2, cap 2. Select. You selected correctly, yeah. And the hypothesized mean difference 0.
Label I
You
have
say
to select, sir.
Label you have to tick an hypothesis mean difference, no difference, 0.
0.
Your output range, where you want the result. Choose output range. Pick output range first, left side. And then you have to choose.
Yeah, placing here.
Either just below. Okay. That's all. Go and give okay. Now you give okay. What is the problem?
Sample as input range
Non-numeric
contains no.
data. Input range contains non-numeric data. Why?
You have
You
not
have to
clicked
change.
label. Label box not ticked.
Okay, yeah, correct. Label you tick. Yeah, right. Now you give okay again. Very good. Now you have become an expert in hypothesis testing. That's all. Most of the factor, validation will require only ANOVA and t-test only. Will require only ANOVA and t-test. Well done, madam. So
Thank
anyone
you, sir.
else ready? You want to try? Maybe somebody with your project data. Let us say an hospital doctor want to check three treatment for diabetics. What is the test? Hypothesis test he should do, the doctor. Whether a treatment is significantly improving the sugar condition, like diabetic condition. This is the test he want to do. What is the test he should do? There are 3 treatments he want to compare. Come on, yeah. What is the test you should do now? There are 3 treatments. ANOVA, right?
ANOVA. Yes.
Yes.
Please tell me, doing ANOVA with the Minitab and without Minitab, which one will require less time? Which one you can do it in lesser time?
Minitab.
With Minitab.
Minitab.
With Minitab.
If somebody want you to
Minitab.
prove that, if somebody want you to prove that using Minitab can save your time significantly, what is the test you should do? With the Minitab, without the Minitab. The time taken to complete an hypothesis test ANOVA. What is this? Either 2 sample t-test or one-way ANOVA. Correct or not?
Yes, sir.
This is called root cause validation. Now, if anybody would like to talk about any specific root cause scenario, we can relate it to hypothesis test and then we can close the day. Let us say temperature is the root cause for poor efficiency. Temperature is the root cause for poor efficiency. Now how will you validate? Temperature has got, let us say, 3 values: low temperature, medium temperature, high temperature. And at low temperature also you have efficiency reading, high temperature also you have efficiency reading, medium temperature also you have efficiency reading. Now what is the test you will be doing now? Low, medium, high temperature, 3 levels.
ANOVA.
ANOVA again. Now temperature is the culprit or not? ANOVA will tell. And temperature will be declared as the root cause if the associated p-value is below 5% in ANOVA. Yes or no? So this is how the root cause analysis can be validated using hypothesis test. Whether shift is the root cause or not. A company is running 3 shifts. Whether the cycle time is higher in any particular shift, and that is again ANOVA. Whether operator skill level, whether operator skill level is significant to the cycle time or not. Again, that is ANOVA. So ANOVA will help you to handle 90% of the situation. Only for 10% of the situation, you may have to look at the other hypothesis test. So don't worry, we will be learning some more hypothesis tests as we progress. Okay. So any questions or shall we wind up here? Wind up panila. Now I will play the song one more time and then we'll wind up. Okay. Now you will be able to understand few terminologies used in that song.
Turning professionals into leaders. Clarity, quality, measurable results, the true Lean Six Sigma presence. From white and yellow, green and black to the master black belt leading the path. Lean Six Sigma with GSK. We measure, we learn, we elevate, we innovate, we set the pace. Driven by vision, excellence. Lean Six Sigma with GSK. When ambition needs clear direction, when work demands precise execution, when effort seeks proven success, that's where the journey meets excellence. Lean Six Sigma with GSK. Training minds, building skills, continuous improvement is our will. Facts over guess, logic over doubt, results speak when numbers come out. Step by step, discipline is strong, defined to control, we move along. Lean Six Sigma with GSK. We measure, we learn, we elevate, we innovate, we set the pace, driving impact, creating excellence with vigilance. It's an excellent Lean Six Sigma with GSK. Lean Six Sigma with GSK. Not just tools, not just charts. It's a mindset shaping a smart starts. From problem solved to leaders made. Driving performance with vision, excellence. Lean Six Sigma with GSK. Turning professionals into leaders. Lean Six Sigma with GSK.
Okay, if there are no questions, I think we can then wind up. Or you have any questions in mind? You want to ask anybody? No?
No, sir.
Okay. Then thank you all of you. Good night.
Okay, sir.
See you
Thank
next
you.
time.
Good night.
Thank you.
Yeah. Bye bye.
Thank you.
Thank you, sir.
Thank you, sir.
Welcome.
Sir.